Hello everyone, so we are back with Leetcode daily challenge. In today's problem we need to find the longest increasing subsequence. So in the question given below we are provided with a nums array and it will have some integers and we need to return the length of the largest increasing subsequence, and it is clearly given in the question it should be strictly increasing. So as in the example given below, like here 10, 9, 2, 5, 3 are given. So the largest increasing subsequence length will be 4. For example, we have to take 2, then 3, then we can take 7, then 101. So maximum length increasing subsequence is 4. And moving back to the third example, since it is strictly increasing, so if we take 7 initially, then all the elements are not greater than 7, they are equal, but due to strictly increasing, so the length of the largest increasing subsequence will be 1. So let us try to solve this question. What should be our approach? So what should be the naive approach? Like for example, in the example 0 1 0 3 2 3. So what can you thought, like initially we can take 0. What if we take 0, then in the next iteration we have to take 1 or not. We have to decide whether we should take 1 or not. If we take 1, we can take 1 because clearly 1 is greater than 0. Then in the next we cannot take 0 because 0 is less than 1. We can take 3, right? So but if we take 3, then our length of the subsequence will be 3. But in another example, the optimal solution will be like taking 0, then 1, then taking 2, then taking 3. The optimal answer, like the actual answer, will be 4. So in this example, the naive approach, what we are doing, we are deciding whether to choose an element or not, right? So this is the main motive of the optimal solution. We have to take decisions, right? What we have to do, we have to take decisions. What type of decision we can take? Whether to pick an element or to not pick an element, right? And we can pick an element. When can we pick an element? When the current element is exactly greater than the last element, right? And for not pick, there is no condition. We no need to follow any condition. So to make these decisions, what we can do, we have to check all the possibilities, right? One thing to keep in mind, we have to check all the possibilities. So it cannot be done through a normal for loop. We have to have a recursive approach. At first, what we have to do, we have to check what are the possibilities if we take 0 into our answer, and then we will call I'm writing here in this page 0 1 0 3, yeah, with another pen, 0 1 0 3 2 3, right? So what we will do, we will take for the current index, right? We will check, we have two decisions, to pick and not pick. After taking these two decisions, what we need to do, we need to recursively call the function for index plus 1, from index plus 1, right? So for this, what we need to do, we need to create a recursive function. Let us call this function f, and it will take like the index, current index. What we can do, we have to also store the last, because to compare whether it is greater than the current element is greater than last or not. So what we can do, we can store the last element, but we cannot store when we move forward with the DP approach, to optimize the code, we have to keep a store of the index instead of last. So what we will do, we have to store the last index. Then this function, as I said, we have two options to pick. So initially the pick can be set to int minimum, right? Now the pick can only be done if the current element is greater than last element. So we have a check if the current means, I mean to say nums of index id is greater than nums of last index as we passed in this function, right? So if this condition passes, then we can pick an element. So when we pick an element, as I said, what we will do, we are taking one element in our length, right? Like the element we are choosing to pick, we are adding one, like it will add one to the length of our final answer, and then we will recursively call this first function for the next index plus 1, and the last index will be, since we have picked the element in this function call, so the last index will be index, right? And for the not pick case, there are no there will be no condition to check for the not pick. So for the not pick, what we will do, we will simply there will be no plus 1 because we are not picking the element. We will just call the function f of index plus 1, and our last index will not change, so the last index will be remain the same. So this is the case. So we are recursively calling the function, but what about the base case? So since we are taking the index into count, so if our index is out of bound, index is equals to nums dot size, like it is greater than the valid index count, then we will return 0, right? So at the base case, the function will return 0 when the index is out of bound, and when we pick the element, it will add 1 to the answer. So we are recursively calling each of the cases. So let us try to code this solution first, then we will move forward with the optimizations what we can do, because it will give time limit exceeded error, because first we discuss the time complexity. This is a recursive call, so it will take a order of 2 raised to power n, because it is a recursive call calling the function 2 times, so it is of order of 2 raised to n, right? So let us try to code this solution first, and then we will move forward with the optimizations. Yeah, so as I said, what we will do, we will take make a recursive function f. What it will take the index, it will take the last index, we will also pass the vector, right? So I will directly move to the our choices. So int peak will be set to int min. Why we are setting it to int min? Because the peak for the peak case, we need to check a condition. So we should have prior set to peak, because we are taking the max of peak or not peak. So what is the condition? If nums of index is strictly greater than nums of last, then what we will do, we can pick the element, and so the peak will be set to 1 plus, we will recursively call the function for index plus 1, the last index will be current index, and nums will be passed, right? And for the not pick, there is no condition, so we can directly take not pick and pick. Yeah, what we will do, we will recursively call the function without adding anything, index plus 1, and the last will be remain same, and the nums, right? And at last what we will do, we will return the max of both, pick or not pick. Like it will give the answer, our maximum answer is provided by taking that element into count or without taking that element into count. And what about the base case? As I said, if the index is equals to nums dot size, so if the number is equals to the index is equals to nums dot size, what we will do, we will return 0. Yeah, so let us try to call this function inside the main function. So let us take the size of the nums array, n equals to nums dot size. We don't need now, but then also I am taking, or we will simply return the function. The first index will be 0, the last index will be -1. Oh, so first of all, right, so in this case, like the last for the first index, like when the function calls, we should pass a valid last, right? So what we can see, like we are having a check, like we are moving back to our good note. Yeah, so we are having a check here, like our nums of indexes should be greater than last, but initially the last index should not be a like valid index, right? So we should pass something which is out of the like array index bound. So we can pass -1, but in this check it will fail, like -1 will give a pointer error because nums array will not have a -1 index, right? So what we can do with this check, we can also have a check like whether our last index is equals to -1. If it is equals to -1 or this condition, so if it is equals to -1, we can pick an element, right? So what we will do, we will pass -1 to the function, and in this condition check, what we will do, if our last index equals to -1 or so if it is equals to -1, then we can pick an element. I think everything is fine. Let us try to run this code whether it works or not. Oh sorry, it will be nums. Yeah, it works fine for this test case because it is small, but when we try to submit this code, it will give time limit exceeded. Yeah, so this is giving time limit exceeded error. So let us try to optimize this code further. Moving back to good note, sorry. So as I said, this function is a recursive call. So for example, for the example 0, 1, 2, 3, 5, what we are doing, if we are in index 0, then we have two calls. We are recursively calling the function in two cases, pick and not pick. So if we pick 0, then we will have a call for 1, 2, 5, right? There is a call for pick, not pick. So what, like if we move down to the any of the call, the result is calculated like for the rest of the array, right? So what if we can store that result and it can be used in another places? For example, if we not pick, then what is the answer, right? So if we try to store this in some places, it can be better, like we can look up directly into that store and we can use that result for the rest of the index, rest of the array, right? So this optimization is called DP, like we are storing the result into some memory. So after storing that into DP, we can directly look up into that DP whether our index is already calculated or not. So as in the function given below, two of the things are changing, right? The index and the last index. So we have to have a 2D array, and it will the first index will be for the index which will go from 0 to n, like n minus 1. So we have a minimum size of n, and the second part is like last index which will go from -1, because we are passing currently in our solution we are passing -1 to the size of the array, like n minus 1 or n right. So there is a big problem. We are passing -1 to this 2D matrix, but -1 cannot be a valid index. So what we can do, we have a like a solution. We can increment the last pointer by 1 plus 1. So in all the cases, like in every places, what we will do, we will just increment the last pointer by plus 1, so that this -1 can be converted into 0 and it will be a valid index for the DP array. And when we try to look up into the DP array, what we will do, we will take last -1, like for the nums array we will just decrement the pointer by -1. So let us try to optimize this code further. We will move back to our Leetcode. Now what we will do, we will take a DP array. It will be a vector, we will name it DP. The initial size of the first part will be n, then it will have a yeah, so the second part it will be n plus 1, because we are from 0 to n, index 0 to 1, because we are incrementing it by plus 1, and then minus 1, we are storing minus 1 initially. We will pass this DP. Yeah, let me copy this thing. Yeah, we will pass this to our function as a reference. Why reference? Because we don't want to make copies and we want to edit the same DP array. Now what we will do, we will check whether our current index and last index is already calculated or not. If DP of index last index is already calculated, this means it will not be equals to minus 1, which is the default value. What we will do, we will return the calculation. Yeah, index and last. And while setting up the max, what we will do, we will set the DP of current index and last index to max of. Yeah, but as I said, we are passing we are incrementing the last pointer by 1. So if it is 0, wherever there is minus 1, it will be 0, and while comparing with the nums part, what we'll do, we'll increment that by 1. Yeah, rest will work fine, but while passing this function, we will pass 0. Yeah, so let us try to run this code, but before that we have to pass the DP to this function's calls also in this function call. Yeah, so let us try to run this code, whether it works or not. Yeah, it is giving some error. Let me check. So this is yeah, so this is the error, we have to also increment the last condition here also, because the index will be in the when we are in the 0th index, so the last will be should be set to 1, right? Because we are incrementing the last by plus 1, so here it will be index plus 1. Let us try to run this code. Yeah, it works fine. Let us try to submit this code. Yeah, the problem passes. So what is the optimization? Instead of this recursive call, which is taking order of 2 raised to n, it almost optimized to order of n square and all. So the optimization cannot be exactly found, because it depends on the how many time the same function call is taking place, or whether we are calling that function or not repeatedly. We are getting optimized answer in the first call only. So this is the answer, this is the solution. I hope it is clear. The main concept was to make those decisions, like to pick or not pick, based on the condition, whether our current index is current element is greater than the last element or not. So since we have to take all the possibilities, we have to have a recursive solution. Then we optimize this recursive solution to store the data of already called functions, and we store that in a DP array, and we look up if it is already calculated, right? So this will optimize the solution, and it will decrement this order of 2 raised to power n. So thank you for watching. Have a nice day. It is 4 AM in the morning and I'm creating this video. Thank you.